Welcome back to the Fierce Fish First Tech Challenge programming tutorial series. Our goal in this series is to provide simple and straightforward guidance in programming an FTC robot. And in today's video, we're going to be initializing Vuforia. So there are a lot of variables that we have to initialize for Vuforia. We have the localizer, which I just set to Vuforia. We have the parameters, which is just parameters. We have trackables, which I set to vision targets. We have just the single trackable, which is the target, and then the listener, which allows us to track the targets a little later. And we'll look at that as well. And then we're going to be using the OpenGL matrix library because essentially we're creating our own matrix system for the field and the targets on the field. So we'll be looking at that as the video progresses, but the two variables we'll need to initialize first in here are the last known location and the phone location. So now let's go into the runout mode loop. So I've encompassed all of the Vuforia setup into one void that we're going to go look at now. And all of this inside of the void would just go up there if you think about it. So this is just initializing it. We're going to set our new parameters and camera monitor view ID. We don't necessarily need this, but we're going to keep it on there. Now, what is it? It's the preview you get on the robot controller phone, but at times, most of the time, this causes the battery to drain faster. So if you don't want your battery to drain as much, you can just delete this whole thing, and then leave that blank like that. But we're just going to leave it. Okay, and then your Vuforia license key. You have to go to the Vuforia website, create an account, and obtain a license key. It is super long. That's my license key right there. And you'd put it as a string for your parameter Vuforia license key. Without the license key, you can't use Vuforia, and it is free. The camera direction on the phones, you can choose front and back. We'll look at a webcam later. We'll look at this later as well, extended tracking. I'll talk about that later. And then this is how you initialize your parameters. It's class factory.getInstance.create Vuforia with the parameters. And that, like I said, that is how you initialize the parameters. Now here, this is how it's going to recognize the vision targets. Vuforia.loadTrackables from asset, and then your asset name is Skystone. Or at least it was Skystone for this season. The asset name is you're going to find that in assets, and you're going to find it's going to be the same name as the XML file for your current season. So in here we have all the seasons from 2016 to present day with Skystone. And so it would be the same name as the XML file in a string. And then it'll be able to find those and it'll start tracking those. We'll look at this later as well. I've commented it out for a reason now. So now this here, we're going to be worrying about target 9, and I'll show you how I got target 9 actually. So I go into assets, let's go to the Skystone XML file. So we're going to be focused on the blue parameter target 1. I just chose that at random, mostly because it was the first target on the PDF online. So the reason I know it's number 9 is because it's the 9th item on the list starting at 0. This is number 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, blue parameter target 1. And so it is therefore referred to as number, let's scroll back down. Where was I? Here. Number 9 in our code. So that corresponds to whatever vision target you're looking at. And I just set the name to blue parameter 1. And then set location. This is actually a method we created here. It's called create matrix. So here, the math here is actually quite intense, but we don't have to worry too much about it as long as we know that X, Y, and Z is the location on the field itself, and U, V, and W are the rotations about the X, Y, and Z axis. So U corresponds to X, stuff like that. So as long as you have this line in here, open geomatrix at translation, we have the xyz dot multiplied orientation get rotation matrix extrinsic. We're using the world axes. And we're going to use xyz because we're going to use third angle. Got degrees and UVW. And then close that off, and that is how we create our matrix in these methods. So now set location. Let's think about something actually. Let me get this here, this very pixelated field. So you can choose your center position to be wherever you want because we're creating our own matrix. I'm choosing to do it in this bottom left corner. So that's going to be X this way, Y is going to be this way, and then Z is always going to be popping straight out of your face. You can do it in the center of the field if you want. I'm going to do it here because it makes it easier for our later, or it just makes it easier for me. That's based on personal preference, whatever you want to do. We can close that. Okay. So now these numbers here are automatically in millimeters, and we have to set the location of each of the targets. So if we're just focusing on the one target for now, I'm going to say, because it's on the blue wall, we're going to go at 0. This is not correct. This is just what I'm using for the demonstration. We're going to say it's a meter away from that corner of the field. So conversion 1,000. And then it has to rotate. Now, let's think about rotations. Let's think about your X, Y, and Z axes. There's this little acronym logic thing we use called the right hand rule. And if you think about it, take your hand, and I wish I wouldn't have gotten rid of the field, but if you take your hand and point your thumb in the direction of, this is your right hand now, and you point your thumb in the direction of whatever the axis is. If you curl your hand, whatever direction your hand is curling, that is what direction the whatever you're trying to rotate will rotate. So with the x-axis, we're going to rotate the target 90 degrees because we want it to, because if it's going to start like flat on the ground, we want to rotate it up towards us 90 degrees. If you think about the x-axis with the right hand rule, y-axis, it's already good, or it might not be. That depends on, it says in the game manual where the location of each of the targets are. For this, I'm just using as a demonstration. There is going to be a y value, or else this target is halfway in the ground. And then your z rotation value, if you use the z-axis, just like that, it rotates it so that it's, yeah, you get the idea. And now we have to set our phone location. So let's say we have an 18 by 18 robot, and the phone is directly in the center on the outer wall of the robot. So I've translated the phone. That is 9 inches in millimeters. And then we do the rotation. I did the rotation on the x of 90 degrees. So that is that. And then the listener. Get listener. That's just getting your instance of the listener. And then you have to put this in front of it. I'm not sure why. It's just a weird thing that we have to do. And then we have to set the phone information in the listener, and we use the phone location, which we did, and the parameters.camera direction. All right, so now we come back up here. Vuforia setup is complete. Our last known location, we're just going to say the robot started in the corner of the field. Okay, and then we're going to wait for start, and then after start is done, we're going to activate the vision targets. Okay, now here I've just set this up for a little demonstration where I'm going to do with the phone and showing you how this works with the vision targets. So we have the while up mode is active. We're going to get the updated robot location, and if it's null, it will cause some problems. Or it won't necessarily cause problems, but it will just return null, and it gets funky that way. We're going to say if it's not null, then we're going to update the location. And then on the phone, we're going to do some telemetry. That it's visible, the name of the target, that's for the tracking, and then the last known location, it's just going to say the location. So now let's go into a new video clip and look at that.
So now let's take a look at our op mode that we created. So I made it autonomous, so we're going to go in here and select the Vuforia tutorial. I'm going to turn the timer off. And then we're going to initialize it, and then you'll see the preview screen for the Vuforia comes up, and I have the vision target loaded on my computer screen. So now I'm going to press play here. It's going to start tracking. Now here, if you see this axis pop up on your robot controller, once it finds the vision target, you know that the Vuforia is working properly.
Okay, so now that we're back here, let's take a look at some of the things I skipped over that were commented out. Alright, so I think the first thing here was the false for use extended tracking. So extended tracking is like when the vision target gets out of range, like the camera can't see it anymore, it uses the frame rates to try to depict where it is now. And this is a pretty cool feature, but it's really known as being inconsistent. So you can take that feature off by using this line of code. And now here you can set this method here is setting how many of the image targets you want it to track at a time. So say you're on the blue side and there's 4 vision targets on the walls on the blue side. So let's say you wanted to use those 4 vision targets. That's how you would do that. Or if you wanted to use also the ones on the sky bridge, and even if you wanted to use a sky stone, you could set that to however many you wanted. And going through this now, I think, oh, this was something, just so you know and you're not confused, this is like something weird that I used for my conversion for my telemetry, because the matrix, OpenGL matrix uses is not a string, so I had to convert it to a string. So I think that's all the things. Yeah, I think that's all the things. So today we learned about initializing Vuforia. And from all of us here at Fierce Fish, we hope you have a great day.